Students, hello. Last class we have started, right? Current density. Yes or no? We have started current density. We have started drift velocity. Yes or no?
Yes, sir.
Students, in drift velocity, we are dealing with some time to remember. I was saying about drift velocity. Velocity is equal to, you remember? Drift velocity means velocity is equal to acceleration into time. Yes or no? Acceleration we have found. Remember, F is equal to ma and F is equal to QE. From there only we found ma is equal to QE and acceleration is equal to QE by m. How much charge is flowing and what is the electric field given and what is the mass of the charge particle. Do you remember or not? So in place of acceleration, we can write E, let a electron is moving charge into E electric field divided by mass into this time is T. This is how drift velocity is related to relaxation time. So let's know what is relaxation time, students. So here we'll learn today, give heading relaxation time, right? Relaxation time. Relaxation time symbolized as tau. Are you getting all? My voice is audible, screen is visible.
Yes, sir.
Yes, sir.
Okay. So let's see. This is relaxation time tau, right, student? It is the time interval, relaxation time. It is the time interval. It is the time interval between, it is the time interval between two successive collisions of electrons with positive ions. Because electrons get attracted towards proton. Yes or no, students? Positive ions in metallic lattice, right? In metallic lattice. Correct. So in that way, you can write, the resistance of a conductor is given by, right? The resistance of a conductor is given by the resistance of a conductor can be given, write the expression, student, R is equal to 2 ml divided by n square tau into A. Just keep this formula in mind. That means n is, student, this is n, right? N is number density of electrons. N is number density of electrons. N is number density of electrons, right? What is E? Electron charge, right? E is electron charge. And what is M? Mass of electron, right? M is mass of electron. And what is tau, students? Relaxation time. Are you getting all? Tau is relaxation
Yes, sir.
time, right? Students, let's take an example for related to drift velocity, right? Let's take an example related to drift velocity. What is the example exactly? Students, see, the example is, so just consider a wire. Let's consider a wire, right? Let's consider a wire of length 4 meter. What is the length of the wire, students? 4 meter, right? Area of cross section, let cross sectional area is, let's also take the cross sectional area is 1 mm square, right? Let's take the area is 1 mm square, right? This area is 1 mm square, area of the conductor, right? And how much current is flowing in that? 2 ampere. Let's 2 ampere current is flowing, right? In the question, this is the physical dimension of the wire. Length is 4 meter, area of cross section is 1 meter square, and current flowing is 2 ampere, right? Student, right? If each cubic meter of the material, right? If each cubic meter of the material contains, right, 10 to the power 29 free electrons, 10 to the power 29 free electrons, find the average time taken, find the average time taken by an electron to cross the length of the wire. Student, understood the question? That means the most important part, what is the most important part in this question? Student, the electron will be moving with a certain velocity. What is that velocity inside a conductor? Drift velocity. Yes or no? Are you getting my point? At what
Yes, sir.
velocity inside the conductor the electrons are moving? Drift velocity, correct? And what is the formula for drift velocity, students? What is the formula for drift velocity? That is equal to I by NEA. Do you remember? Yes or no? How much current is flowing? Given in the question, how much current is flowing? 2 ampere. 2 ampere current is flowing. No need to write 2 ampere. That is 2. Then what is the number density, students? Number density means number of electrons in cubic meter. That is how much given in the question? That is 10 to the power 29, right? 10 to the power 29 into, students, see here, area. What is the area? 1 mm square is given, but we have to take in meter square, na, students? 1 meter, how much millimeter? 1 meter is 10 to the 2 centimeter, right? That is equal to 10 to the 3 millimeter. Are you getting? So if it is 10 to the 3 millimeter square, then it has to be how much? 10 to the power 6 millimeter square, right? If I will take 1 meter square, then what is the area? 10 to the minus 6, right? Then 1 mm square is how much meter square, student? 10 to the minus 6 meter square. Are you getting or not? Are you getting on? So in place of area, we can write 10 to the minus 6. All agree? And what is charge of electron? 1.6 into 10 to the power minus 19. So you solve the whole thing, you will get that is 12.5 into 10 to the power minus 4 meter per second. So with this speed, the electrons are moving inside the conductor. Are you getting, students? And he's asking in the question, average time taken. Student, velocity you got. How much distance he has to cover? 4 meter. So velocity is equal to distance by time. Yes or no? Yes or no, students? So average time taken, right? Average time taken by an electron. Average time taken by an electron to cross the length of the wire. To cross the length of wire. That is, velocity is equal to distance by time. So you want to find time. Time is equal to distance by velocity. The distance is 4 meter and the velocity is 1.25 into 10 to the power minus 4. Yes or no? So by solving, you can get t is equal to how much? 3.2 into 10 to the power 4 second. All understood the question? Manaswini, Soumya, Narayan, Susri, Swastik, understood?
Yes, sir.
Very good. Next, let's go to another part here. Give heading mobility. Right? Let's know what is mobility. Get acquainted with the scientific terms associated with current electricity chapter. What is mobility? Right? Students, mobility means what? Mobility means right, mobility of a charge carrier. Let charge carrier means we are focusing on electron, right? Right, mobility mu of a charge carrier like electron is defined as the average drift velocity resulting from the application of unit electric field strength, right? Students, what is the drift velocity is defined as the average drift velocity. You know, average velocity, total displacement, how much? In how much total timing? Let we are giving electric field. In electric field, the charged particles move. Yes or no? F is equal to QE. In the first chapter, we have learned of electrostatics, right? Getting the students? So after application of electric field, the charged particles are moving. And in a particular interval time, what is the total displacement? That is known as mobility. Mobility drift velocity per unit electric field. How much electric field you have applied and what is the average drift velocity. So that means you can write mu is equal to, students, just remember, that is drift velocity. Mu is equal to drift velocity divided by electric field. Drift velocity divided by electric field. That is mu is equal to, formula you can write Vd divided by electric field. Just keep in mind this formula. Mobility is something Vd by electric field. And student, mobility depends, let you are increasing the temperature. So the thermal energy will be converted into kinetic energy. So there is a probability of getting more collisions, right? And if you are also increasing the pressure is equal to what? Force is equal to pressure by area. So if you are changing the pressure also, then it will be getting affected, temperature. So you can write here a point. Mobility depends on pressure and temperature. Mobility depends on pressure and temperature. Getting, students? Then the most important law that you have already learned in class 10th, right? I'm coming to that. That is, give heading Ohm's law, right? Give heading, student, Ohm's law. Now let's start with it. It's very easy for you. Ohm's law. Write the statement. For a given conductor, at a given temperature, the strength of electric current through it, for a given conductor at a given temperature, the strength of electric current through it is directly proportional to the potential difference applied across its end, right? Applied across its ends, right? It's a law. Keep it in heading, right? So that means, students, you know from your early classes, I proportional to V and I is equal to V by R. So combinedly you can write V is equal to IR. You know this or not? R is the electrical resistance of the conductor, right? R is the electrical resistance. R is the electrical resistance of the conductor. right, students? So that is, student, Ohm's law is neither a basic law nor a derivable one, right? It's just an empirical relation, right? So we can write microscopically, Ohm's law can be expressed as, students write microscopically, Ohm's law is expressed as J is equal to NEVD, correct? J is equal to NEVD. So student, J is equal to, right, sigma into E, right? J is equal to sigma into E, and right, sigma is the electrical conductivity of the material, right? Sigma is the electrical conductivity of the material. And student, the conductors which obey Ohm's law, the conductors, students, here actually the thing is that more electric field will be applying, more current density, right? J proportional to E. And what is the proportionality constant? Sigma. Sigma is the electrical conductivity of the conductor. You are acquainted with J, you are acquainted with E, and sigma E, right? And student, sigma is the electrical conductivity of the material. And the conductors which obey Ohm's law are called ohmic conductors, right? Example, all metals. The conductors which obey Ohm's law are called ohmic conductors. Are called ohmic conductors, right? Example, all metals. And should ohmic conductor means the VI graph is a straight line, right? Right, for ohmic conductors. For ohmic conductors, VI graph is a straight line. VI graph is a straight line passing through the origin. Passing through the origin, right? That means, see here, student, that I have taken here V, voltage, dependent axis, I, current, independent. This is the slope, right? Theta. Student, what is slope? Slope is tan theta, you know. Tan theta is equal to V by I, that is equal to R. Yes or no, students? Are you getting? So more slope means more resistance. That means if I'm drawing two lines, let this is V and this is I, correct? So this is one graph, this is one graph. This is T1, this is T2, this is 1, this is 2. Let this angle is theta 2 and this angle is theta 1. Student, which angle is greater? Theta 1 is greater, right? Than theta 2. So if theta is greater than tan theta 1 is going to be greater than tan theta 2. So resistance of first R1 is going to be resistance of R2. R1 is greater than R2. Are you getting that? Students, getting or not? Student, the substances which don't obey Ohm's law are known as non-ohmic conductors. That's right. The substances which don't obey Ohm's law, the substances which don't obey Ohm's law The substances which don't obey Ohm's law are called non-ohmic conductors. Are called non-ohmic conductors. Underline non-ohmic conductors, right? So for example, students, we'll be doing the graphs of those, right? You will be learning about in your higher classes. Here also thermistor, thermal resistors, right? That the temperature with the increase in temperature, the resistance varies. There is a device thermistor, right? Electronic valve, right? Electronic valve, semiconductor devices, gases, crystal rectifier, right? Student, for a ohmic conductor, for a conductor, the VI graph is ohmic linear. So for a non-ohmic conductor, VI graph is going to be linear or non-linear? Semi? Non-linear, right? The VI graph of a non-ohmic conductor, non-ohmic means which doesn't obey Ohm's law, right? Of a non-ohmic conductor is non-linear. Correct. Non-linear means it could be of any type. Let we will be saying vacuum tubes, right? Let we're saying vacuum tubes. Let this is current, this is voltage, right? So it will be like this for vacuum tubes. Let for another chapter is there, semiconductor, the last chapter of 11th, right? 12th. So that is semiconductors, how the current and the voltage related. So this is plus X, this is plus Y, this is current I, this is voltage, right? It is somehow like this. In milliampere, we're saying the voltage, right? Understood, students?